You came across this question in your chemistry exam. How will you solve it? It is very easy. Now let's solve together. The question says, a sample of an oxide of mercury weighed 1.00 grams. When this was heated, oxygen was given off and 0.962 grams of mercury metal only was left. Now, what is the question? The question now says, what is the formula of the oxide? Wow. Now, they said something very key at the end. What is the formula of the oxide? First of all, what is an oxide? Listen. An oxide is a compound that is made up of two elements. Listen. An oxide is a compound that is made up of what? Two elements. Now, what are these elements? The first one is oxygen. You can say from the word oxide. So you looking at the word oxide, one of the key elements that will be present is oxygen and another element, which can be a metal or a non-metal. But in the course of this question, they said oxide of mercury. So this oxide is made up of oxygen and mercury as an element. Mercury is an element, so you should note that. So mercury is symbolized as Hg. If you don't know that before, know it from today. Mercury is symbolized as what? Hg. Now listen very well. This question is very easy. Initially, they said that a sample of an oxide of mercury, meaning that this is the oxide of mercury, oxide of mercury. All right, we're not done. Just watch. They told us that this sample weighed 1.00 gram. So the mass of these two elements combining together is 1.00 grams. You listen very well. Now, they now said something very key. They said, when this oxide was heated, heat was applied. They heated the oxide, oxygen was given off. Oxygen you are looking at was what? Given off. And 0.962 grams of mercury metal only was left. The question now says, what is the formula of the oxide? Now, listen. In chemistry, whenever you are asked to calculate or determine formula of compounds. Formulas in this aspect can be of two types. It can be what we call empirical formula or can be what we call molecular formula. In questions like this where they will say, what is the formula? Most of the time, they want you to calculate for empirical formula. And there is a method, there is a way to do that. But if they wanted us to calculate for molecular formula, we are going to see something, because you have read through the question. We are going to see something in the question, and that thing is called molecular mass. So in this question, we did not see anything like molecular mass. So this question is not asking us to calculate molecular formula. What they are asking us to calculate for is empirical formula, and I'll be teaching you on how to do that. So first of all, to calculate empirical formula is simply to bring out the elements you are interested in. The elements that makes up the oxide of mercury is mercury itself and oxygen itself. So you can see we've brought out the elements. The next thing to do is simply to write out the masses of the elements under them. You understand? In some other questions, you will not be giving masses. All right, you saw mass now grams. You'll be giving percentages. So it's same method. You just listen. So in this case, we saw mass, grams, so it's mass. So what we need to do is to put the masses of the element under these elements we've written. So let's read the question again to know what we have to do. Listen, they said that when this sample was heated, oxygen was given off and 0.962 grams of the mercury metal only was left. So from this question, the mass of mercury itself is 0.962 grams. Are you there? If you observe carefully, there is no place in this question they actually gave us the mass of oxygen, because I just told you that we need the masses of both elements to solve for the empirical formula. So what do we do to get the mass of oxygen? It is very easy. Listen, because the question is not direct. They gave us the mass of oxygen indirectly. Remember the mass of the sample. Remember The mass of the sample, which is made up of oxygen and mercury altogether, is 1 grams. Are you there? And also you are aware that this sample, which is made up of oxygen and mercury together, I believe you know that it is when you add the masses of the element that makes up the sample, you get the total mass. So this sample is made up of mercury and as well as made up of oxygen. So what do we do to get the mass of oxygen? Because we already know the mass of the sample and we already know the mass of mercury. The mass of the sample is 1 grams. The mass of mercury is 0.962 grams plus mass of oxygen, which is unknown. So for we to get the mass of oxygen is very easy. This mass of mercury will come over to this side. When it crosses equality sign, it's going to be minus. So oxygen will not be, the mass of oxygen will not be 1 gram, all right, minus 0.962 grams. So mass of oxygen will now be 0.038 grams. So this is the mass of oxygen. So you can see how we got the mass of oxygen. Even if in this question we are given the mass of oxygen, we're not given the mass of mercury, you still do the same method. You will now make mercury subject. For instance, they did not give you the mass of mercury. So this we've got here, we are going to impute it here. So it's become 0.038 grams of what? Oxygen. So you can see, let's now start to calculate the empirical formula. To do this very easy. Now the next step, after writing out the masses of the element under this element, you divide both of them by their atomic masses. Most of the time, they'll give you in the question, they gave us the atomic masses of the element. Under mercury, divide by the atomic mass. Listen, the atomic mass is 200.59. All right, that's the atomic mass. For oxygen, atomic mass is 16. So you divide by the atomic mass to get the value. So I will not tell you next what to do. So when we divide 0.962 divided by 200, we are going to get 0.0048. All right. Let's do the same thing for oxygen. When we divide, we are going to get 0.0024. You can see we've divided by the atomic masses and we got all of these numbers. After you determine these values, you then divide by the smallest, all right? You divide both numbers by the smallest, all right? Looking at these two numbers, which is smaller? This is smaller because this is 0.00, 0.00, and here is 48, here is 24. So this is smaller. So then we divide both of them by the smallest value, 0.0024, and here is 0.0024 as well. So when we divide this and divide this, here we are going to get 1. So when we divide this by this, what are we going to get? So when we do that for this, we are going to get 2. So these values we have gotten at the end is what we call the mole ratio of the element, all right? The numbers that will be attached to the element. Now, with this information, remember, this is for mercury. So here, Hg will now be 2, you understand? Whereby O will be 1. You know, you can also decide, you know, in chemistry, whenever an element has 1 beside it, it's like saying nothing. So me having 1 here, I can just decide to remove it. You understand? But when it's more than 1, like 2 above, you leave it because it means something. So this we've gotten is the empirical formula. Now in chemistry, what does empirical formula mean? Empirical formula is the simplest formula of a compound. This is the simplest way this compound can exist. There's no way I can break it further. For instance, here was 2. I can say because they were the same, I can cancel out. But in this case, you cannot cancel because this is the simplest way it can exist. That's why the question specifically is asking us for empirical formula. So based on what we've gotten, what becomes the answer to the question? All right, it's actually option A because I told you already that this 1 there, you can start to remove it, all right? Because 1 means nothing, or you can still write it here as well. It's not option B that is HgO2. No. This is Hg2O1. You understand? And not option C and the rest. So I'll be giving you a practice question so you solve under this aspect. Okay, guys, here is your own practice question. A sample of an oxide of copper in this case. All right, we'll be using copper as the metal, weighed 1 gram. I'm going to change the mass of, you know, the metal, which is copper. And in this case, it is 0.799 grams of copper metal, So you have to calculate the formula for me. And I believe you know that it's empirical formula you're looking for, EF. Then I'm going to give you the atomic mass for copper. Atomic mass is 63.5. Oxygen atomic mass is 16, doesn't change. So this is your question, and make sure you provide the answer in the comment section. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons to your friends. Thanks for watching. To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.